in example 2, we are going to look at how to graph in standard form. The key features start with finding the vertex that we found in example 1. So let's take a look. First thing you're going to do is identify what are the A, the B, and the C. We are going to utilize the C in this example, unlike we did in the first example when you find the vertex, because that will be helpful for another part. But the first part is what we did in the last one, which is find the vertex. So we're using the formula H is equal to the opposite of B over 2A. In this case, you're going to end up with 2. Evaluate for 2, and you get the y-coordinate is 4. So the vertex is at 2, 4. The axis of symmetry is the vertical line that goes through that point, so x equals 2 in this case. To find the y-intercept, you evaluate the function for 0. But what will always end up happening, if it's in standard form, is the y-intercept will be the c value. So the c value you identified at the beginning is just going to be the y-intercept. And if the y-intercept is already the vertex, which can happen, you'd have to find another point. So once you have the y-intercept, you can get a reflection point, or a point that's symmetric to this point, by identifying how far the y-intercept is from the axis of symmetry. In this case, it's 2 units away from the axis of symmetry on the left, meaning that the reflection point will be 2 units away on the right. So in this case, it would be 4, 8. Once you have a vertex and 2 other points, in this case, the y-intercept and its reflection, that's enough to draw your curve through it. So let's take a look at another example. This one I want you to try on your own. So at this point, you can pause and we will go over it together once you try it. I went ahead and worked out the key features, and then I'll demonstrate the graphing live. So the x-coordinate of the vertex opposite of b over 2a ends up being opposite of -6 is +6. 2 times 1 is 2. 6 divided by 2 is 3. So once you end up with 3 as your x-coordinate, you evaluate the function for that. You're substituting 3 into the function, and you're ending up with -10. So the vertex is at 3, -10. Axis of symmetry is at x equals 3, and the y-intercepts are at 0, -1, and 6, -1. Well, the y-intercept's at 0, -1, the reflection is at 6, -1. First thing I noticed is that the graph does not include 3, -10, so I'm going to need to zoom out to be able to see that. And I can also scroll down. All right, so when I go to plot 3, -10, 3, -10 is down here. So what I'm going to do is I'm just going to drag the vertex down to 3, -10. All right, and then the y-intercept's at 0, -1. That actually doesn't look too bad, but let's actually move the point. Well, actually, it doesn't appear to let me go on that side. So I already know that the reflection point is at 6, -1. So let me put the point right there. And there you go. We can check. That actually looks pretty good compared to what they had. All right, let's take a look at example 3.